All right, we're going to jump into the periodic table, and we're just going to jump straight into the questions. How many valence electrons are in the group 8 elements? All right, so on this periodic table, it clearly shows you group 8, okay? And we marked up our periodic tables in the classroom to sort of be very simplistic like this. But what you guys need to know is sometimes you're not just going to see it as 8. Sometimes you're going to see it called group 18, or you may see the Roman numeral 8. Okay, so you need to be able to recognize that group 18 and that this Roman numeral 8 is going to be the same as this regular 8. All right, so how many valence electrons are in group 8? Well, there's 8 valence electrons. Okay, remember valence electrons were the electrons in the outermost shell of the atom. How many valence electrons are in group 3? Well, again, you'll see that either as 13 or you may see it as the Roman numeral 3. Okay, and there would be 3 valence electrons in group 3 or 13. How many valence electrons are in carbon? Well, let's find carbon. It's right here. It's in group 4, so that would mean it has 4 valence electrons. Again, you might see this called group 14, or you might see it as XIV, which is the Roman numeral for 14. Okay. Oh, I'm sorry, this would not be the Roman numeral for 14. This would be the Roman numeral for 4, IV. Okay. Number 4, how many valence electrons are in silicon? Si is going to be right here. So how many valence electrons would be in there? That would be 4. How many valence electrons would be in the element under silicon? Okay, why are we asking that question? We first asked how many valence electrons were in carbon, how many valence electrons were in silicon, which is right below carbon, and then they're asking how many valence electrons would be in the element under that. Well, all the elements in this one group are all going to have the same number of valence electrons, okay? So it would be 4. And then the element under that one would also have 4. Okay, it would just be 4 in this whole group. It would be 3 in this whole group. It would be 5 in this whole group. Okay? Would the elements helium, neon, and argon be stable or unstable? Well, let's find those. Helium, neon, and argon are in group 8. Okay? Group 8 has 8 valence electrons, which makes it extremely stable. Okay, meaning the atoms don't want to bond easily because they are happy with the number of electrons that they have in their valence shell, okay, in their outermost shell. So that makes it very stable. You do need to know that, okay? These are called the noble gases. I'm not sure if you need to know that, but you do need to be aware that these elements that are in group 8 or 18 are very, very stable. Why? Because they all have 8 valence electrons in their outermost shell. Okay. Why are the elements in group 8 stable? We just talked about that. And they all have 8. Or we'll just say their valence shells are full because helium does not have 8. Because their valence shells are full. Okay, so they have the exact number of electrons in their outermost shell that they want. What do we know about all the elements in the same group? So what do we know about all these elements and all of these elements? What do we know about them? Well, we know that they all have the same number of valence electrons, okay? So we could say that they all have the same number of valence electrons. Okay, well, what's important about that? Well, that means that they're all going to react similarly. Okay, so they would react similarly. In other words, they'll all kind of bond similarly. Why? Because they all have the same number of valence electrons. Okay, so they're all going to be very similar. All of the elements in the same group are going to be very similar. They're going to have very similar characteristics. And we'll just say similar characteristics. Make sure you guys know this, okay? All right, number 10. Oh, sorry. Which group of elements, which group includes the elements with the most similar properties? Okay. I almost went over this one. So, which group of elements which group includes elements with the most similar properties? So let's look at this first one. Sodium is over here, right? I'm going to put a star by it. Mn is, where did I put that? Where is that? I wrote all over this and now I don't see it. Let's jump to the next one. Mg, magnesium, is going to be right here, okay? And Mn, still looking for Mn. Okay, but these two are not in the same group, so they are not going to be very similar. Okay, so we could cross through that one. F, fluorine, this one. Chlorine, right below it. And bromine, right below it. Are those going to be similar? Yes, they are. Why? Because they're all in the same group. So it's going to be B. Okay. The next one, number 10. Label the parts of the periodic table above, include the following: metals, nonmetals, and metalloids, and noble gases. Okay, so I already told you guys where the noble gases are. Your metalloids are going to be these grade in elements. They have characteristics of metals and nonmetals. Metalloids. Right here, the stair step, remember those? Okay, and then your metals are going to be this section, and your nonmetals are going to be to the right. Nonmetals, all of these. Metals, nonmetals, metalloids, and noble gases. Remember, the noble gases are very stable. Okay, which element behaves the most similar to lithium? So let's find lithium. Here's lithium. All right, so which one's going to be the most similar to lithium? Beryllium? Over here? No, it's not in the same group. Potassium. Here's potassium. All right, so potassium would be the most like lithium. Why? Because it's in the same group. So it would be potassium. Why? It's in the same group. Okay.